Okay, so we're going to talk about inverse sine, inverse cosine, and inverse tangent. Now, when you do this in your calculator, of course you know how to do that, right? How many answers does the calculator give you? One. That's because there's only one answer. It doesn't say, oh yeah, remember you're going to do this or this. So if you wanted to know the inverse sine of -1, okay, what does that mean? Where is sine equal to -1? So we go to the unit circle and we say, okay, where is that? Unit circle. And pi? I don't think so. That's -1, 0. 3 pi over 2. Okay? Now, if you do this on your calculator, you have to be pretty slick to do it. But first of all, you are going to do, make sure, typically, we want to make sure that we're in radian degrees. Okay? So, radians is really what we want, but if we're trying to be slick, we're going to switch it to degrees, because we'll recognize degrees, we won't recognize radians. So, I'm going to switch it to degrees temporarily, okay? And then I'm going to do inverse sine of -1. And what should the answer be? Because it's not going to be 3 pi over 2, because that's radians. How many degrees is that? No, it's not going to be that either. 270, that's right. Oh, you were right, it's -90. Okay, so that means 3 pi over 2 is not the right answer, is it? Okay, so we got to talk about restrictions. It isn't, no. -90 goes like this little guy right here. 270 goes like this. Okay, they land in the same place, but you know we can think of 1,000 different names for that same angle, right? So, there is one answer. It's not 3 pi over 2. What is it? Nope. -pi over 2. Okay, so before we even, now, we can come back to these because that's already been brought up. I'm trying to get him minimized. Okay. I'm going to go to the next page, and these are the restrictions. Now, I use that word. I don't know about your teacher last year. Did your teacher last year talk about restricted? You were right. I know. I'm talking to the other guys. Okay, well, I don't know what he or she used, but it's, here's the restrictions on inverse sine. Okay. So this is a negative. I know it disappears sometimes. Inverse sine of x equals y. Y has to be in between this guy, this is -pi over 2, and this guy. So anywhere right here. Okay? Those are the same restrictions that the calculator understands. That's why it didn't give us 270, it gave us -90, because that's in that area. Now who can explain why we're using these two values, these two quadrants, and not these two as well? Hey. Okay, so sine's positive in here, and sine is negative in here. Sine is positive here, all students. Sine is negative here. These are just reruns of these. So if we use two quadrants, first and second, well, first of all, we're real short. Rotation from your, what do you call this? Do you remember? I can't even remember what it's called right at the moment. That's why I asked you. That's where your starting ray is. Initial ray. There you go. And we're starting there, and we either go this way if we want to go positive, or we go this way if we want to get negative. Okay, so either one in these quadrants were real close. Okay, all the way around isn't close. So that's why there's two reasons. We catch them all the values, all the positive signs, all the negative signs, and we're close to the initial rate. Okay, look at tangent. Tangent has the same restrictions. Okay, because it's the same reason. Tangent is positive here. Tangent is what over here? Negative. Tangent, of course, is positive here, and tangent is negative there. So we catch all the positive tangents and all the negative tangents if we grab those two quadrants. Okay. However, look at inverse cosine. They're different. Okay. Inverse cosine, all students take calculus. Of course, we're going to grab the positives there. But why aren't we going to go down here and grab this one? It's still positive. That's right. So that's why we have to go over here. So we're grabbing all these angles. Again, the closest rotation to this, we're not going to go all the way over to the third quadrant. That's a rerun of those. And this is a rerun of those. So we got to grab them all. Okay, so that's the reason for the restrictions. Let's try a couple. Do we need to go? Okay, let's go back here. This is the first page. Inverse sine of -1 or arc sine of -1, just to be clear, is negative pi over 2. Okay? Now, there are literally 8,000 things that you could say about that, but that's not what you want. You want the one value. Okay, where's the cosine -1? Where is the cosine -1? At pi? Okay. Because if you look at a unit circle, we're talking about -1, 0. Good job. Okay, where's the tangent? -1. Don't say it out loud. Where is the tangent? -1. All right, now Lizzie, you can say it out loud. Excuse me. Oh, Lizzie. See this face? Disappointment. Oh my goodness. Kelsey? Yes. Very good. Oh, yeah.
And for Layla's.
Oh, yeah, factor. You got to remind. That's the reason we're doing this, because they're like, oh, yeah, we've done this. Okay. But remember, tangent is sine over cosine. So we have to figure out where the sine and the cosine are the same. That's right here. Well, in order to be negative, we need to be in that second quadrant, fourth quadrant. Okay. All right. Good job. Inverse cosine of 1/2. Again, where is the cosine 1/2? Of course, we know it's either here or here. No, here. Sorry. Calm down. All right. Which one is it really in? First or second? Fourth, third, fourth. First. Okay. Where now? You are remembering, boom, 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 all these guys. 1, 2, 3, divide by 2, divide by 2, divide by 2, take the radical. Okay? And then do the other side. Start up and go on up to 1, 2, 3. Okay. So where is the cosine 1/2? Right here. Pi over 3. Okay, if you need to, you draw yourself this. This is pi over 3. What's the middle one? You can almost read those. Pi over 4. And the little one is pi over 6. Okay? All right, don't say it out loud, but where is the sine negative radical 3 over 2? Okay. So the whole thought process, you got to think about it. All right, inverse sine. All students take calculus. We must be in what quadrant? Fourth. Okay. Negative radical 3 over 2. Well, here's a positive radical 3 over 2, so that's pi over 3. In order to get down here, we're talking negative pi over 3. This negative will put it in the fourth quadrant, and then this will give you that value, radical 3 over 2. I don't want you to take the time to fill out a unit circle every time you have a test. You're doing like 10 minutes worth of work that you only need 2 values on that whole circle. You can figure it out as you go. Okay, so inverse sign of 0. Where is the sign 0? I'm thinking we're back over here now. Where's the sign 0? Remember, sign is here or here, but we're not positive. So where's the sign 0? Make. Hook. At 0, that's right.
And you know that it's 0 and not 2 pi because that's not within the branches, right?
Correct. Okay. That's correct. Beautiful explanation.
Pi, buddy. It's 0. I did that too, I'm sorry.
0. Okay. All right, let's try these 3 down here. I'll just let you do them. They're all, I don't know why that inverse thing disappears on that little one. But. All right, do those 3. Grab my circle. That other one's a weird one. The third one. Get the first 2. And the third one is
It's not that
the
bad.
others.
I don't think.
Do I?
I think I got it.
All right. Y'all got the first 2? Okay. What is the inverse sign of radical 2 over 2, Jenna? Pi over 4. Very good. What is the inverse cosine of 1, Kenzie? 0. 0? Very good. Okay. All right. Now, this one is not S. Okay, but who had that? Be honest. You really didn't have that?
No.
Okay. Okay, let me get on the page here. I thought that would be your answer. What was your answer? Wow, aren't you smart? Okay.
That's the first time you said that to us.
Okay. I don't know about that. Okay. What's the kind of rule? The inverse of the regular function should be what? Right. Should be x.
Yeah.
Okay. Well, why isn't that one negative 3 pi over 4 then? Thank you, Lizzie.
Redeem herself.
Oh my God. Okay. Did everybody hear what Lizzie said? Say it again. Yeah. Right. Negative 3 pi over 4 is in what quadrant? Second, because it's third. It's over here. 3/4 pi is a 4th pi short of negative pi, right? Okay. There's not any of the functions that are in that third quadrant. We have first and second and first and fourth, none in that third quadrant. Okay, so you want, first of all, what is the tangent of negative 3 pi over 4? Is it positive or negative? Positive. Okay, so you still want to stand by your negative pi over 4 answer? No. Pi over 4.
We know that.
Because this is positive. Right? So that means it's either this one or this one that have the same value as this one. Well, the only one that has the same value is the one that's positive, which is the 4th quadrant, which is pi over 4. And those are those vertical angles again. Okay? Now, if you go back to your calculator, inverse tangent, I'm still in degrees, tangent of negative, I'm going to go back to radians, so I don't have to switch that up. All right? negative 3 pi over 4, parentheses. Okay. See, it's not negative pi over 4, it's pi over 4. Okay. So if you haven't switched back your mode to radians, because that's what you really wanted in, is radians. Even though they don't ask, they want answers in radians. Okay? So we're going to talk about that. And remember, x has to be a restricted angle. Territory, whatever, I don't know.
Is there a way to have another pressure air come out in radian form?
In terms of pi? No.
Yeah.
No. You have to
We
put
wish.
pi in. You have to do what I did. But see, that's why if you want to be really slick, put it in radian, put it in degrees, and then when you put in this pi in up here, you would just put in 180 instead. So you just put pi times 180 divided by, oh wow. It's time, no.
You did do.
Okay. Times 180 divided by 4.
You have 2 negatives.
I do. You're right. It always does more than I think. Get impatient. Imagine that. How's that, Hannah? Okay. Now I want to make sure I'm in radians or degrees because I'm putting in degrees. Degree, enter. And there we go. 45 degrees. Okay. And then you know that is pi over 2 right there. Okay? All right. So we're going to do some more of those just for practice on your handout. Let me get back. Here we go. Stop recording.